Hello everyone. Here we are going to solve examination style questions from probability. The first question is, room in hotel are numbered from 1 to 29. Rooms are allocated at random as guests arrive. What is the probability that the first guest to arrive is given a room that is an even number? Now see, we have total 1 to 29 rooms, out of which if we see how many rooms are having even number and how many rooms have odd number. So as we can see, there are 29 rooms. Out of these 29 rooms, as it is starting with an odd number and ending with an odd number, the number of odd number rooms is going to be more. So here number of odd number room is going to be 15 and number of even number room is going to be 14. Total 29 rooms. Now the first question is, what is the probability that the first guest to arrive is given a room that is an even numbered? Now even number, how many even numbers we have? 14 even number rooms we have out of total 29 rooms. So my answer is going to be 114 divided by 29. B question. The first guest to arrive is given a room which is an even number. So already one guest has given a room which is an even number. What is the probability that the second guest to arrive is given a room which is an odd number? Now we have 15 odd number rooms and the total number of room now available is going to be 28. So the answer for B will be 15 divided by 28. First room is already allotted. Okay, that is even number room. So the number of odd number room will still remain 15, but the total number of room will decrease by 1. So your answer will be 15 divided by 28. Second question. The table shows the grades gained by 32 students in the history test. Now here you can see the grades as well as you can see the number of students who scored these grades. Okay, so like grade 3, only one student got. Grade 4, there are 2 such students. Now the first question is, write down the mode of the data. Now this is probability chapter, but it may include with some other topics. So this mode, median, mean, they are from statistics. Now what is mode? Mode is one that has maximum number of repetitions. So as far as grades are concerned, grade, we can see that grade 6 is repeating maximum number of time. So for A, my answer will be mode is equal to 6. Now second question. Second question is, work out the median. Now what is median? Median, if I arrange these grades in ascending order, the grade which is present at the centermost position is considered to be the median. Now to find median, what we can do, we can make one more column, that is your cumulative frequency. So here at the bottom only I will write the cumulative frequency. So here it is 1. Now 1 plus 2 will give me 3. 3 plus 3 is 6. 6 plus 9 is 15. 15 plus 8 is 23. 23 plus 5 is 28. Plus 4 is 32. Okay, so if I arrange numbers like 3, 4, 4, 4, 5, 5, 5, 5, 6 times and so on, I have to find out where is my middle number. Okay, for that what we can do, this is 32, last number is 32, not 34. Okay, what I will do, I will find out what is 32 divided by 2. So 32 divided by 2 is your 16. Okay, so at 16th position and at 17th position I will see what number we have. So at 16th position, like till 15, okay, the last 15th number, I will say that is going to be 6. Then after that 16, 17, 18, all those numbers are going to be 7. So here if you are asking me median, I will say that median is equal to 7. Now as the data is even, so if you arrange them, you will find two numbers at the center. Now in this case, the number at the 16th position and number at the 17th position, they are in the middle. We should take the average of those two numbers. Now here both the numbers, number at 16th position and 17th position, both are going to be 7. So their average is also going to be 7, and hence your median is 7. Now see, calculate mean. Now how we calculate mean? So for that we arrange all grades and divide by total frequency. Now when frequency is given, that is the repetition is given, so addition can be converted in multiplication. Like if 5 I have to add 3 times, I can say it is 5 times 3, 5 into 3. So here to find mean, what we do, we multiply grade with its frequency. So 3 times 1 plus 4 times 2 plus 5 times 3 plus 6 times 9 plus 7 times 8 plus 8 times 5 plus 9 times 4. Okay, I will multiply and add, and then I will divide this with total, which is 32. Okay, so here if I do the calculation, it is 3 times 1 is 3 plus 4 times 2 is 8 plus 5 times 3 is 15 plus 6 times 9 is 54 plus 7 times 8 is 56 plus 8 times 5 40 plus 9 times 4 is 36. Their total is going to be 212. So 212 divided by total number is 32, total frequency. Okay, so here if you want to write formula, it is summation of fi xi divided by summation of fi. Okay, what I'm saying, it is summation of fx divided by summation of f. Okay, so this is equal to 212 divided by 32. So 212 divided by 32, answer is 53 divided by 8. Okay, so 53 divided by 8, this is in simple form, and if I convert that in decimal, it is 6.625. Okay, so whenever we are writing answers in decimal form, it should be up to 3 significant figures, but here it is up to 4 significant figures. That is perfectly okay if it is not keep on continuing. Okay, now D, 2 students are chosen at random. Calculate the probability that they both gained grade 7. Okay, now 2 students, so we have to find the probability that they both gain grade 7. So if you see, there are 8 such students. So first student is getting grade, okay, grade 7. It is going to be 8 divided by 32. Then second student getting grade 7 is going to be 7 divided by 31. So 8 7 are 56. So your result is going to be 56 divided by 32 times 31. So 32 times 31 will give me 992. So 56 divided by 992, which is equal to, if I say in simple form, 7 divided by 124. 7 divided by 124. The result is 7 divided by 124. Okay, so this is your answer for D. Now let us see answer for E. Question E, Let me create some space. So A, B, C you have done. Now E is from all the students who gained grade 6, 7, 8 or 9, 2 are chosen at random. Calculate the probability that they both gain grade 8. Okay, so now my choice is now not from 32 students. It is from the number of students who scored grade 6, 7, 8 or 9. So grade 6, 9 students have scored, grade 7, 8 students, then 8, 5 students, and then 9, 4 students. So 5 plus 4, 9 plus 9, 18, 18 plus 8, 26. Okay, so I have to select from 26 students only. So from all the students who gained grade 6, 7, 8, 9, which is 26 such students, 2 are chosen at random. Calculate the probability that they both gain grade 8. So how many students gain grade 8? It is 5 students. So your answer for E, question E, will be 5 divided by 26 multiplied by 4 divided by 25. So 5 times 4 is 20, divided by 26 times 25 is 650. So in simple form, 20 divided by 650 will give you 2 divided by 65. So 2 divided by 65 is answer for E. Now F, students are chosen at random one by one from the original 32 until the student chosen has a grade 4. Calculate the probability that this is fourth student chosen. Okay, now here the first student, okay, who score grade 4 until the student chosen has a grade 4. So what they are saying, probability we have to find that the fourth student choose a grade 4. That means the first 3 students, okay, they choose a grade which is other than 4. So there are 2 such students who scored grade 4. So out of 32, I will say that the possibility that the first student is choosing a grade other than 4 will be equal to 30 divided by 32. Then the second student choosing grade other than grade 4 is 29 divided by 31, and the third student will be 28 divided by 30, and fourth student, he is choosing grade 4. So like this, I have 2 students, so it is 2 divided by 29. Okay, so here the result numerator, if I figure out, it is 30 times 29 times 28 times 2, which is 48720. 48720 divided by denominator is 32 times 31 times 30 times 29 times 29, which is 863. 863040. Okay, so in simple form, it is 848720 divided by 863040. So final answer is 7 divided by 124. So this is your question F. Calculate the probability that this is the fourth student chosen. So fourth student, okay, getting grade 4, we will find like this. First 3 students, they are choosing a grade which is other than grade 4. Now let us move to question number 3. Question number 3 is, Scott goes to school by bus. The probability that the bus is late is 0.2. If the bus is late, the probability that the Scott is late to the school is 0.7. If the bus is not late, the probability that Scott is late to the school is 0.1. Okay, so these kind of problems are better solved using the tree diagram method. Now, the first scenario is that whether bus is going to be late or not late. Okay, on time we can say that, late or on time. Okay, now probability that the bus is late is 0.2. So possibility that bus is not late is going to be 0.8. Now, if the bus is late, the probability that Scott is late. So Scott is late. Again, the possibility that the Scott is late is given 0.7. So he is not late. Its possibility on time, we can say that on time. Let us write T only. Okay, so T stands for on time. It is going to be 0.3. Now, if the bus is late, okay, if the bus is not late, on time, sorry, if the bus is on time, then the Scott late to the school, its possibility is 0.1. So on time, it is going to be 0.9, right? Now let us see the first question. The first question is, calculate the probability that the bus is late and Scott is late to the school. So bus is late, its possibility is 0.2, and Scott is late as the bus is late, its possibility is 0.7. So my possibility that the bus is late and the Scott is late is going to be 0.2 times 0.7, which is 7 divided by 50, or we can say that it is 0.14. Now question B. Calculate the probability that Scott is late to the school. Now probability that Scott is late to the school. So now when we are saying that he is late to the school, that means we are talking about the condition that when bus is late and Scott is late, or we are talking about the condition that bus is not late but Scott is late. Okay, so here one by one we will see. First, bus is late. Calculate the probability that Scott is late to the school. Bus is late is 0.2 and Scott is also late is 0.7, or bus is not late and Scott is late, it is 0.1. So this will give me 0.2 times 0.7, which is 0.14, plus 0.8 times 0.1, which is 0.08. Final answer is 0.22. Okay, now C question. The school term lasts 35 days. The school term lasts 35 days. How many days would Scott expected to be late? Now here we see that the possibility that the Scott will late is 0.22. Okay, so if we consider 35 days, we will say that 0.22 times 35, because this possibility always gives me the result out of 1. So one day Scott is late, its possibility is 0.22. So for 35 days he is going to be late. Okay, its frequency is going to be 35 into 0.22, which is about 7.7. Now 7.7, if we see number of days, we should round it off. So here 7.7 days, it indicates that approximately 8 days Scott is supposed to be late. Okay, so here the concept of relative frequency came into picture in this question C. Tree diagram also is an important feature that we have seen in this problem. Okay, now question number 4. Question number 4 is, the tree diagram is already shown. The tree diagram shows a testing procedure on light bulbs taken from a large batch. Each time a bulb is chosen at random, the probability that it is faulty is 0.02. Okay, write down the value of P and Q. So here each time bulb is chosen at random, the probability that it is faulty is given 0.02. So this P, value of P is going to be 0.02. Okay, so here for A, I will write P is equal to 0.02 and Q, which is a possibility that it is not faulty, is going to be 0.98. So 0.02 and 0.98 are the values of P and Q. Okay. Now the second question, two bulbs are chosen at random. Calculate the probability that neither are faulty. Okay. So two bulbs are chosen at random. Calculate the probability that neither are faulty. So neither are faulty. That means first bulb is not faulty. Its possibility is 0.98. And second is also not faulty. Its possibility is 0.98. So the possibility that both the bulbs are not faulty, it is 0.98 times 0.98. So 0.98 times 0.98 is 0.9604. 0.9604. Okay, so 0.9604 is your result for B. Now C. Question C is, if exactly 1 out of 2 bulb is tested faulty, then a third bulb is chosen at random. Calculate the probability that exactly one of the first 2 bulb is faulty and the third one is not faulty. Okay, C question, what it says that if exactly 1 out of 2 bulb tested is faulty, then a third bulb is chosen at random. Calculate the probability that exactly one of the first 2 bulb is faulty and the third one is not faulty. So exactly one of the first 2 bulb is faulty. That means either your first bulb is faulty, whose possibility is 0.02, then your second bulb is not faulty, 0.98. Okay. Or your first bulb is not faulty, which is 0.98, and your second bulb is faulty. So this gives you a condition that exactly one of the first 2 bulb is faulty. Now, after knowing this, the third bulb, when I pick what is the possibility that calculate the probability that exactly one of the first 2 bulb is faulty and the third one is not faulty. Okay, so now what, the third bulb is not faulty, so its possibility is what, 0.98. So this indicate the possibility that exactly one of the first 2 bulb is faulty, and this indicate that the third bulb is not faulty. So as we are using the word and, there is a multiplication. Okay, so please keep your focus on the terms we are using, the words we are using. So 0.02 times 0.98 gives you 0.0196. So I will multiply this by 2 and the whole result I will multiply by 0.98. So the final answer we get is 0.038416. So in decimal, it's a very big number. Now, as this is a terminating decimal, we can keep this as it is. Okay, so see, the possibility that exactly one of the first 2 bulb is faulty and the third bulb is not faulty is 0.038416. Now D, the whole batch of the bulb is rejected either if the first 2 chosen are both faulty or if the third one need to be chosen and it is faulty. Calculate the probability that the whole batch is rejected. Okay, so again, the whole batch of the bulb is rejected either if the first 2 chosen are both faulty or if a third one need to be chosen and it is faulty. Calculate the probability that the whole batch is rejected. Now, what is the condition for whole batch to be rejected? Is that your first 2 bulbs are faulty. Now, the possibility of first two bulb being faulty is 0.02 times 0.02. So if this condition happens, then we reject our batch, or we reject our batch when it is said that the first two chosen are both, if either the first two chosen are both faulty, or if a third one need to be chosen. Now when third one need to be chosen, when exactly one of the two is faulty, then we are choosing the third, as it is indicated in the part C. Okay, third is chosen and third is faulty. Okay, and it is faulty. So here your result will be 0.02 times 0.98 times 2 times 0.02. Okay, now understand here, 0.02 into 0.98 into 2, this indicate that exactly one of the two bulb is faulty. Okay, when two bulbs are chosen, and this indicates that now the third bulb is chosen and that bulb is also faulty. So let us do the calculation. It is 0.02 times 0.02, okay, plus 0.02 times 0.98 times 2 times 0.02. Okay, so here your result is 0. This is a very rare possibility, 0.001184. Okay, so this is the possibility that you will reject the batch of bulb. Calculate the probability that the whole batch is rejected. This is the possibility that whole batch is rejected. Now E, if in 1 month 2000 batches of the bulbs are tested in this way, how many batches are expected to be rejected? So for E, out of 2000, the possibility of rejecting a batch is 0.001184. Now out of 2000 batches, how many we will reject? So we will multiply this whole possibility by 2000 and the result is 2.3. So 2.3 batch we are rejecting, that means 3 batch. So we will say that we will reject 3 batch, or better we round off to the lower side, because here this is possibility exactly we don't know. So 2.3 indicate that 2 batch are rejected. So we will reject 2 batch. A very interesting question. Okay, lot of concepts will clear from this question. Okay, now this is your question 4. Let us move to question number 5. Now this is your question 5. All 28 students in a class ask if they like tennis and if they like badminton. Some of the results are shown in the Venn diagram. So information is already, some of the information is shown in the Venn diagram. Your universal set is set of students in the class. T is students who like tennis. B is students who like badminton. Total 28 students are there. 6 we have written outside. So one thing, that if I add this 8, 9, 6 and say here it is x, their total is going to be 28. So here if I figure out what is x, it is x plus 8 plus 9 plus 6 should give me 28. So that gives me x is equals to 28 minus 8 minus 9 minus 6, which is 5. So this x value is 5. Okay, so now I can answer the question. The first question is, how many students like both sports? So you can see 9 students like both the sports. Then how many students do not like either sports? So like this, I have 6 students who do not like any sports. Write down the value of number of T union B. So T union B, here T union B will be equal to 8 plus 9 plus 5. Okay, number of T union B. Okay, so which is equals to 8 plus 9, 17, 17 plus 5 is 23, 8 plus 9 plus 5. Yeah, it's 22. So write down the value of T union B. So T union B, I will use T intersection of both, and this, their total is 22. Using formula also we can find out. Now formula no need to apply here. D, question D is write down n of T intersection B complement. Now T includes 8, 9 and B complement include 8, 6. So if I see what is common, so this 8 number is common to them. E, a student from the class is selected at random. What is the probability that this student likes tennis? Now, one student you are selecting and you have to find out that the student like tennis. So I have 17 such students out of total 28 students. So 17 divided by 28. And if a student who like badminton is selected at random, what is the probability that this student like tennis? Okay, so this is conditional probability. A student who like badminton. So how many students like badminton? So 9 plus 5, 14 students like badminton. Out of 14 students, I have to select one who like tennis as well. So like this, I have 9 such students. So 9 divided by 14. Okay. So this is your question number 5. Okay. Now question number 6. Question number 6 is 2 students are selected at random from a group of 14 boys and 13 girls. Find the probability that they are both boys. So probability that the first student is a boy, I will say that 8 is 14 divided by, now 13 plus 14 is 27. So 14 divided by 27 times the second is also a boy. So it is 13 divided by 26. So 14 into 13, your numerator is going to be 182 and your denominator 27 into 26 is going to be 702. And in simple form, it is 182 divided by 702. Your result is 7 divided by 27. 7 divided by 27. Okay, this is A. Now B. Part B is 1 is boy and the 1 is girl. So 1 is boy and 1 is girl. If your first student being a boy, its possibility is 14 divided by 26. When second is girl, it is 13 divided by 26. Or you have first student as a girl, which is 13 divided by 27, and the second is a boy, which is 14 divided by 26. So this result is, we can simply say that this is 14 divided by 27 into 13 divided by 26 multiplied by 2. Okay. So your answer is 14 divided by 27. Okay. So this is the possibility that 1 is boy and 1 is girl. Now next question. Next question is your 7th question. 7th question is, a play is being performed twice. First on a Friday and again on Saturday. 100 people who wanted to see the play were asked which of the two performances they could attend. 58 people said they could attend the Friday performance, and 74 students said they could attend Saturday performance, and 4 said they could attend neither. So here in the Venn diagram, I will write 4 here who say that they cannot attend performance on any of the day. Now there could be some who can attend on Friday and Saturday. I don't know their number, so let me consider them as X. Now on Friday, 58 people said that they attend on Friday. So here 58 minus X will be here, okay, which is the number of people who can only attend on Friday. Okay, this X can attend on Friday or Saturday. So if I add this X here, the total number of students attending on Friday will become 58. Now on Saturday, 74 said that they will attend on Saturday. So 74 minus X will give you the number of persons who can attend the play only on Saturday. Okay, so I can work out the value of X here first. Okay, so how we can work out? So your 58 minus X plus X plus 74 minus X and plus 4. The sum of all these will be equal to 100. Okay, so this minus X plus X we will cancel, and X will be equal to 58 plus 74 plus 4 minus 100. So the value of X we get is 58 plus 74 plus 4 minus 100, 36. So that means there are 36 students who can attend the play on both the days. 58 minus 36, that is 22, can attend only on Friday, and 74 minus 36 they can, which is 38 in number, so they can attend only on Saturday. Okay, now let us go to the question. The first question: complete the Venn diagram to illustrate this information. So okay, this is what we did. Now F, those who could attend on Friday, as those who could attend on Saturday. So A part we did. Now B part. So B part is, what is the probability that a randomly selected person from the 100 questions could attain either performance, could attain both the performance. So like this, I have 36, so 36 divided by 100. Okay, second question. So this is first question of B. Second question is, could only attain the Saturday performance. So could attain only on the Saturday. So like this, I have 38. So 38 divided by 100. And third, could not attain the Saturday performance. Could not attain the Saturday's performance. So like this, I have, so could attain the Saturday, could not attain the Saturday performance. Wait. The second part, could only attain the Saturday performance. Could not attain the Saturday performance. So 100 minus 38. 100 minus 38, that is total 62 out of 100. Okay, so they cannot attain, this is a possibility that they cannot attain Saturday's performance. And the C question is, if one customer who wanted a ticket for Saturday performance accidentally bought a ticket for the Friday performance, what is the probability that they could still be able to go? Okay, so I have 36 such number who can go on Friday or Saturday. Now here, if one customer who wanted a ticket for Saturday, so if the person wanted ticket for Saturday, means that person could be out of 74%. Okay, so 36 divided by 74, okay, will be your result. Now this C part is your conditional probability. So 36 divided by 74. Still, I'm confused about this third question of this B. Could not attain the Saturday performance. Could not attain the Saturday performance. Okay, right. Here, it is not 62. It should be could not attain the Saturday's performance. So total 74 people who can attain Saturday's performance. So could not attain Saturday's performance will be this 22 and 4. So that is 26. I will say that 26 people out of 100 will not be able to attain the Saturday's performance. Okay, so this is your seventh and the last question from exam style questions. Okay, so this examination style questions, what I find are very useful, okay, as they cover majority of the type of problems that you may encounter in your exams. So all the examination style questions you should solve. Thank you for being with me and solving all these problems. I will see you next time with few more interesting questions from probability. Thank you.